All right, welcome. This is chapter 6 on fats and other lipids. So, we're going to begin with part 1 today, looking at more or less the biochemistry of lipids and fats. And then in part 2, we will look at more along the lines of the effects of fats and lipids within the diet and the nutritional implications of that. So, I wanted to begin with talking about how lipids are the second major type of macronutrient we're going to be dealing with. Remember, last week we did carbohydrates. This week we're focusing on lipids, and they are uh, more or less oil and water don't mix. Okay, they are characteristically defined as here insoluble in water and less dense than water. So you see that when you mix them with water, the lipid layer is going to be on top. These types of chemical characteristics are what we're going to be focusing on mainly today, and how that derives the different types of fats, fatty acids, triglycerides, phospholipids, and cholesterols. Fats are needed in the body. They have 9 calories per gram. So it is almost double, or it is double the amount of energy in protein and carbohydrates. So it is integral in maintaining cell membranes, hormones, adipose tissue is the storage form of fat, and it can be used for ATP. That's why we can lose body fat. Okay, we can burn excess adipose tissue, and also it's needed for absorbing the fat soluble vitamins A, D, E, and K, as well as ooh, tastes so good, right? Fats give foods that high satiety, that rich flavor, that buttery, creamy, oily texture, and that a pleasing aroma. When we look at our first type of lipid that we're going to look at, or the first type of fat, we're going to be looking at fatty acids here. So you see that fatty acids are simply a hydrocarbon long chain. It's a long chain of carbons all linked together with this acetyl group here on the end and an omega group on the end. So, um, saturated, so fatty acids are divided up into really 2 major types based on the number of bonds. So you see here carbon only has 4 bonds, and so you see that this is a saturated fatty acid because all of the carbons that you see on this long chain, this hydrocarbon chain, are fully bonded. Okay, so that is what we call a saturated fat, where each carbon atom within the chain is completely filled with hydrogen atoms. That then leads us to what happens when these carbon chains are not fully bonded. So when you have one carbon chain that is double bonded here, this is known as an unsaturated, or excuse me, a monounsaturated fat. Well, let me go back. The category unsaturated, okay, meaning they're missing a hydrogen bond here. And then there are types within that. So saturated fats, completely bonded. Unsaturated fats are either mono unsaturated or poly unsaturated. So if it's mono unsaturated, you see where it's there's only one double bond within the carbon chain. And if it's a poly unsaturated fat, you see that there are 2 or more double bonds within the carbon chain. And this right here is an example of one you may have heard of, the omega-3 fatty acid. Okay, omega-3, only omega end, bond 1, 2, 3. Okay, the location of that double bond. Unsaturated is better for us only because this saturated chain here, it's really hard for the body to break that down. fully bonded carbons, and it can contribute to plaque in the arteries. And this is what makes the food solid at room temperature, such as your butters, your lards, Crisco, that type of thing. And we'll talk more about saturated fats and how we can make man-made trans fats here in just a second. You also have what's known as essential fatty acids. Okay, there are two particular types of polyunsaturated fats that cannot be made in the body, cannot be produced in the body, so we need to get them in our food. And this is your alpha linolenic acid and your linoleic acid that you see here, that omega-3 that we talked about earlier, and omega-6. So these are found in your nuts, your seeds, your legumes, and must be consumed in the diet in order to have that essential quality. So your polyunsaturated fats here, your omega-3, which is an essential, your omega-6, which is an essential, and you see here the different types of DHA, fatty acids, EPA, and AA. These are the terms that you'll see on the actual bottles of supplements if you take a supplemental fish oil or omega-3, whatever type of fat supplement you take. Then we talk about trans fats. Okay. Oh, actually, let me go back. I didn't mean to skip that. Essential fatty acid deficiencies, which there again is uncommon in the United States because really we do have a high, not necessarily a high fat. We're definitely high carbohydrate as a nation. Um, but essential fatty acid deficiency is, I have seen a lot in clinical practice as far as poor wound healing, scaly skin, dry skin, hair loss, that kind of thing. So something to look out for, but usually not a major concern. The only time I've ever seen a fatty acid deficiency, excuse me, in clinical practice was in my frail elderly people who just weren't eating enough in general. Then we have trans fats. So trans fats you see here is this unique uh, placement here of the hydrogen in this bond. Okay, so it's an unsaturated fatty acid where the hydrogen of the double bonded carbon are on the opposite side. So you see here this cis form. Cis means same side. So you see where both hydrogens are on the same side. And then when you change that, okay, when you transform it, trans means other side. So you see where the hydrogen is now on the other side. So you wouldn't think that it's that big of a difference, but it really is in the way that the body is able to metabolize that. It's found naturally in certain foods, like in fried foods, or excuse me, in certain meats and dairy products found naturally. But as far as in our current diet, it's really become an issue and a harmful substance that we consume in the form of partially hydrogenated oils. This is where food manufacturers on purpose convert a cis fatty acid into a trans fatty acid. And that produces a partially hydrogenated oil. And this is beneficial to the food manufacturers because it makes food solid at room temperature, makes them not become rancid quite so quickly. This is why the Twinkies can sit in the vending machines for months, maybe a year, and still, be fresh per se, because they have taken a healthy natural trans fat and turned it into a partially hydrogenated fat, which is really difficult for the body to deal with. And these partially hydrogenated oils are, there's a lot of research out there with the FDA and the health risks involved. And here in a second, when we actually look at a food label, you'll see that by law, they only have to list a certain amount. So there's a lot of hidden trans fats or partially hydrogenated fats in foods that are not even by law needed on the food label. So, and it's a huge difference when it comes to your LDL and HDL cholesterols and those kind of things, which we'll talk about here in a second as well. Our next type of fat is what we call triglycerides. Okay, tri meaning three, glycerols meaning the fat here. So the triglycerides are composed of three fatty acids that you see here, and actually they are these tremendously long chains of fatty acids, but here in this slide, it's condensed. And you see where they're attached to this glycerol backbone. About 95% of the lipids in the body, in the foods that we eat, are in the form of triglycerides and fats and oils. And the fats that we eat, excuse me, in turn are metabolized into triglycerides into energy and stored in the body as adipose tissue. So we see these types of triglycerides in saturated fats, monounsaturated fats, polyunsaturated fats, trans fats, all of those that we've just talked about. Wanted to look at the cellular kind of chemistry here related to phospholipids and why fats are so important and essential. So you have this phospholipid bilayer where you have the hydrophilic, okay? Remember, blood is majority water, so hydro, okay? And then this hydrophobic layer here, where your fatty acids. And this is what allows the transport here of components in the bloodstream, okay? And you have naturally found phospholipids in the form of lecithin, which is one of the major phospholipids in the foods that we eat, in the egg yolks and liver and wheat germ, and your nuts and your legumes. This is why eggs are used as an emulsifier, okay? Phospholipids kind of act that same way. These phospholipids functions as emulsifiers in the body and help keep water-soluble and water-insoluble components mixed together in the blood, as you see here. You also have these tiny integral parts here within that phosphorobilayer called cholesterol. Okay, that might sound familiar to you. This is the next group of lipids we're going to talk about. And notice how they're structurally, they're chemically fatty acids, but they're structurally look a little different in this ring-like structure here. There are many different types of sterols, but cholesterol is the main one you might be most familiar with. Cholesterols are found in animal foods, and your liver makes cholesterol, okay? Cholesterol is made in the human liver along with bile, and it is needed for storing, or excuse me, it's needed to have vitamin D be maintained and stored and used in our bones and muscle and nerve cells. It is integral also in the production of hormones, okay, your steroidal hormones, where estrogen and testosterone are an example of that, as well as bile, which we talked about before. And if you remember, I think it was chapter 2, I believe, where we talked about digestion in general and where fats are absorbed and the function of the liver in producing bile and storing that bile in the gallbladder for use. And we'll talk about that here in a second, in the duodenum of the small intestine. You also have another type of sterol that is not cholesterol, but known as your stanols. Okay, these are your plant-made sterols and your phytostanols here. They're not well absorbed in the human intestinal tract, but they are really good at competing for that cholesterol absorption in the gut. And that is why you see here how these plant sterols, excuse me, Uh, these phytosterols and phytostanols are integral or can be integral in reducing some cholesterol level. Um, So I was going to go down a rabbit hole with that, but I think I'll refrain from right now. Moving on. So now that you know about fatty acids, you know about cholesterols, you know about the stanols, you know about the essential fatty acids, hydrogenation, trans fats, and your phospholipids. Let's now look at how fat or lipids and fats are digested. Okay, so they begin with the salivary lipase and in the mouth. Okay, in other words, everything begins in the mouth with an enzyme, and it really takes off in the duodenum or duodenum of the small intestine, where you have that primary site of lipid digestion. So the chyme that you eat that is comes from the stomach is going to stimulate this cholecystokinin that is going to release that pancreatic lipase and bile from the gallbladder. And all of that is going to aid in the emulsification or the breakdown here of the hydrophilic and hydrophobic heads and tails that we talked about in order for us to be able to absorb it in the gut. Okay. So we have to kind of use these bile salts, which help us to absorb these fats. Uh, the so this is a wonderful diagram here from your textbook that talks about those steps we just went through. You see the salivaric lipase here, the breakdown of the gastric lipase here, entering into the small intestine, and how you have the bile salts coming from the liver, the pancreatic lipase coming from the pancreas, all help to take that fat, kind of emulsify it, break it down into its different components, triglycerides, cholesterol, fatty acids, monoglycerides, those kind of things, and eventually get absorbed through the chylomicrons within the small intestines. Okay, you see these absorptive cells here, and eventually working their way down, here into the lacteals and the chylomicrons um, into the bloodstream. We have not really talked a whole lot. I think we mentioned it back in when we talked about body systems and we talked about the lymphatic system. And you see here the lymphatic lacteals here within the microvilli of the small intestine. Same kind of concept, but the lipoprotein lipase enzyme here in the capillary wall is what's going to break down that triglyceride and help to transport them throughout the body, as you see here. Okay, these absorptive cells kind of eventually help that get absorbed into the small intestine, into the bloodstream. Okay. Enterohepatic circulation here. Not to get too bogged down into this, but it shows where this biliaric tree here, the bile salts, how they come from the liver, get put here into the duodenum here of the small intestine, along with that pancreatic lipase that we spoke about earlier. Fats give us 9 calories per gram. Okay. And we can use adipose cells for energy, stored fat for energy when needed. And when we look at the amount of fat with the American diet, it is recommended to be 20 to 35% of our total overall calories. You see here where the average fat intake was on that high end range. And Per the older dietary guidelines, cholesterol, trans fats, and saturated fats were recommended to be eaten less of. All of these fats that you see right here, the wonderful poly and monounsaturated fats in all of these foods, in your avocados, your walnuts, your nuts, your salmon, your olive oil, all of those are wonderful and can be and should be part of a delicious, uh, healthy diet. And real quickly here, before we end this part one, I mentioned briefly here earlier how, or excuse me, where fats are going to be listed on the nutrition facts panel. So I kind of wanted to end here by looking at the nutrition panel. So just like last week, we looked at total carbohydrates and how you have added sugars and fiber. Right above that, you're going to find total fats, and that is broken down into saturated fat and trans fat. And all, also, you will often see even further breakdown if the food contains polyunsaturated or monounsaturated fats and cholesterol, that will also be listed. Okay. So since this is a quote unquote flatbread or a type of cracker, it's not an animal-based product. So it's naturally going to be cholesterol free because remember cholesterol is only found in animal products. And overall, this is a pretty healthy product fat-wise because of only 3 grams of fat and only one of those being saturated. So when you are looking at nutrition facts labels, you want to always pick one that has 0 trans fats. And that still does not mean you're getting none or by law, if it has, I forget, but if it has less than 0.5 grams of trans fats, they don't have to list it. I need to look that one up. It might have been a while since they may have changed the law since then, but in other words, this trans fat could have like zero point 0.4 or zero point 0.3 grams of trans fat in it. And really any amount of those PHOs, partially hydrogenated oils, are really a no-go. So would not recommend those. So we're going to end here for part one of chapter 6 with lipids. And when we come back for part 2, we're going to talk about some of the health risks and cardiovascular diseases and atherosclerosis diseases and those kind of things. Okay. Let me know what questions you have.